This lecture will be talking about a spatial data format modeling, what we call time series data. So the outline looks like this. First, I'll be discussing about how the time series problems are different than non-time series problems, okay? Then I'll be explaining about what is the difference between stationary and non-stationary signal. And based on these two topics, I will be building on some very well-known and standard time series model, what you call auto-regressive integrated moving average. This actually covered three different modeling ideas: auto-regression, moving average, and then ARIMA model. Let's first understand that how the time series problems are different from non-time series problems, okay? So far, we have talked about regression and classification models, and if you pay attention, these models are actually learning the relationship between y and x. Okay, so given x, you want to learn a function f that will predict y. Okay, if the y is actually numeric values, then we are calling it as a regression problem, and if y is a categorical variable, then we are calling it as a classification problem. So the general structure of a time series model follows this. So here again we are learning a function f that explains y at time index t given x and a bunch of y's, so these y's are actually, so if you are predicting at t, you might also include the values at t minus 1, t minus 2 and up to t0. What we are telling, we want to predict the value of y at time index t by using all the previous values of y and a bunch of x. X's are the same kind of features that we have seen for non-time series IID problems. Okay, this is the general structure, but if we actually drop x, then this is a purely time series model. Okay, so what we are saying that we want to predict the value of y at time index t by using all the previous values that we have observed. Okay, so this is purely a time series model. Let's recap. So if y is dependent on x, then this is the regular regression or classification problem. And if the yt is dependent on x and all a subset of previous values of y, this is a general time series problem. But you can drop x and only predict y based on the all or a subset of previous values of y. This is a purely time series model. So just keep it in mind. Okay, now we'll be talking about the difference between stationary and non-stationary signal. So all the signals that we observe can be categorized into two classes. One is what we call stationary and the other one is non-stationary. So most of the real world signals are actually non-stationary. And how to differentiate between stationary and non-stationary signal? One primary idea of non-stationary signal is it will vary over time. Here you can see that this signal is varying over time in terms of trend, right? And these two signals are actually varying in terms of their values. Okay, so if I read out, a time series is said to be stationary if it does not display any trends or seasonality. Okay, so in particular this one is not showing any trend, neither a seasonality. Okay, so you might observe this kind of pattern like the weather. Okay, so the weather changes as per the seasons, right? Even the temperature in a day, because at night the temperature actually drops down compared to the day temperature. Okay, a time series is said to be stationary if it does not display any trend or seasonality. Okay, so we are talking about this particular case. So if it doesn't show any trend or seasonality, then it's considered to be a stationary signal, and the opposite, like if a signal either shows a trend or it has the seasonality aspect, these kind of signals we call as a non-stationary signal. Okay, so one more way of defining stationarity is when data doesn't have any time dependent mean, variance or covariance. Okay, so let's move forward. How to actually make a non-stationary signal stationary. Okay, one of the standard technique is that you take the difference between each subsequent steps. Okay, So you have a time series which is defined through S. So you are converting S into a T, and T here is a stationary signal. So we are actually taking the difference of the subsequent timestamp of the non-stationary signal. Okay. If you run this equation, then you will have the value of big T at time T is the difference between signal T and minus the value of the previous timestamp, and you just carry on. Okay. Another way, you just take the ratio, so st minus 1, and then you divide by the value at st minus 1. So here we are actually showing two examples of how we make a non-stationary signal stationary. This is clearly a non-stationary signal, and here this is a stationary version by taking the subsequent timestamp differences. And this is another stationary version where we just do the difference and then do the ratio. Okay.